Okay, welcome to the Monday, May 21st, 2018 meeting of SIG Apps. My name is Kenneth Owens. I'll be hosting today. The meeting minutes are posted into the chat, and let's get started. So, the first thing we've got is Shipper, which is multi-clustered canary deployments using Helm charts. If B. Tyler is there?
Yep, that's me.
All right, Ben. Okay, do you want to share your screen?
Absolutely.
Cool.
Okie dokie. I'm going to have to flip between a few windows, but I guess to start out with, this is about a thing which is not yet open source, and I'm here basically trying to get information from the community about whether this is something that is interesting to you or whether we sort of solved an internal problem and nobody really cares. If folks are kind of saying that, yes, this is cool stuff and we think it's interesting, then we're hoping to open source this in kind of Q3, early Q4. So I'll be on SIG Apps Slack afterwards if we run out of time for discussion. So for context, I work at Booking.com and we're deploying Kubernetes, and we wanted to treat our clusters a little bit more like cattle. We wanted to have a larger number of smaller clusters. Part of that is we wanted to make a deal with our application developers that we expect their application to be deployed to multiple clusters in multiple regions and multiple data centers, such that as the kind of operators of the clusters, we can take any one of them down for maintenance at any given time, or because we made a bad configuration change, or because etcd is sad, or whatever, operational stuff. To make that more palatable and not just pushing burden onto the application devs, we built a deployment tool to handle that for them. So what you're looking at in this diagram is overwhelming. I probably should have waited to share it, but that's okay. The gist of it is we have kind of this control plane, data plane separation where we have a dedicated Kubernetes cluster where we run our deployment operator called Shipper and the set of CRDs that Shipper operates with. And then the controller takes those CRDs and then orchestrates a bunch of application clusters on your behalf. So for example, and the analogy here is that we have an application object, which I'll show you the details of in a minute, not meaning to step on any app CRD development work, so we'll probably rename that before we open it up to the world. But for now, the word is application. You have an application object in your namespace in the management cluster, which has a template which corresponds to an individual release of that application. So you edit the template of the application, it creates a new release. Just like when you edit a deployment object, it creates a new replica set. It's one-to-one. So like if you want to go do a thing, you create or edit an application object in the management cluster, and we orchestrate that change out to all of the clusters on your behalf. So now I'll kind of switch to software doing stuff. So for context, great. So you all should be able to see a Google GCP dashboard now. So we have a bunch of clusters. I have a management cluster, which is where my software is running, and then I have 4 application clusters spread throughout the world. So Europe, US, Australia, Asia. What I'm going to do is create an application resource in the management cluster. Actually, all of my kubectl interactions will be with the management cluster. I'm not actually going to touch any of these 4 application clusters directly. And then we'll kind of see what happens by looking in the workloads dashboard along the way. So to start out with, I'm going to flip over to my terminal. I apologize for the awkwardness. I wasn't familiar with sharing screen on Zoom, so there's going to be some back and forth. Okie dokie. So I'm just to give you a kind of quick overview over what an application object looks like. This is what I'm going to create into the management cluster in a namespace called demo. Namespaces in management are one-to-one with namespaces in application clusters. So kind of if you have permission to do something in the management cluster in a namespace, the same permissions apply to you in the application clusters. The application object consists of a template, kind of like a deployment, where we have a chart, and this is the actual stuff we're going to deploy, a set of cluster selectors to target where you want to put it, a strategy, which defines how you will do this rollout. And this is where we can kind of decide, do you want to do something that feels like blue-green, something that feels like canary? How aggressive or conservative do you want your canary process to be? The strategy I've defined here is not at all conservative, and I'll describe what it's saying right now. So it's a sequence of steps, each of which have a capacity component and a traffic component. So for capacity, this represents the percentage of a full kind of final state for one of these identities. So either incumbent, the old release, or contender, the new release. And so what we're saying is in step 0 of my strategy, my old release should be at 100%. It should still be, doing all of the work. The new release, the contender, should have a single pod or 1% of its capacity. And this is something that you might run Selenium checks against. It's sort of a staging position. In terms of traffic splitting, the incumbent, the old release, should be at 100%, and the contender should get nothing because we're still running our Selenium or whatever. Who knows? After that, we'll very kind of aggressively advance to a 50-50 split. So we'll say we'll scale down the incumbent to half of its total capacity. We'll scale up the contender to half of its total capacity, and then also set up a 50-50 traffic split. One note I want to kind of explain here is that we're doing traffic splitting with only vanilla Kubernetes services and labels on pods. So we're not doing any service meshy stuff here. We wanted to make sure that kind of anyone could use this without having a particular service mesh installed. We will probably, we know what we're going to extend into doing more service mesh things later on, but for now it just does vanilla, kind of like what you see in the Kubernetes docs for doing a canary deployment. And then so the last step of the strategy says my old release goes down to 0 for capacity, my new one goes up to 100. Same thing with traffic. The final part of our application is the values, which is what we parameterize the Helm chart with. And so just like, this is like doing -- set or dash values file when you're using Helm on the command line. So this is how we plug in or override the defaults of the chart. So with all that stuff said, I'll go ahead and create it, and we'll start to see stuff happening. The app I'm going to deploy here, the workload, is a small HTTP server, which just echoes what Google Cloud region am I in, what's the name of my Kubernetes cluster, and what's the label of my release. Great. Just long enough to stop my heart. So I can see I've created an application object, and also that I've created, accordingly, a release object. So if I go back to Google now, my dashboard, let me flip the screen. Oh, actually, yeah, great. And I refresh. We'll see that a whole bunch of deployments have showed up. And because, of course, demo, the controller needs to be restarted. I'm sorry about this. Give me 1 second. Of course, it works 5 times before I start. But so I've installed a bunch of deployments into a bunch of clusters, and I'm expecting my multi-cluster orchestrator to scale them up to the position they should be at in the first step of the strategy. And so that should happen shortly. Should also create a bunch of services for me. Great. And then we can look at our application object and see exactly what I created there, but also some status fields. So for example, am I in the middle of aborting a rollout? Do I have a release according to my template? What releases do I have? Am I in the middle of a rollout? That kind of thing. If I look at the release, you can see that whole template has been snapshotted into the release object.
The Google screen.
Oh, I'm sorry. Thank you very much. I think I'll just do the whole desktop and then I'll avoid this problem anymore. Okay, you guys can see everything now, right?
Yes.
Okay, wonderful. Thank you. Sorry about the jumping back and forth. So I've snapshotted that application template into my release object. I'm looking at a release object here. And we can go down and look at the conditions and the status and kind of see like what's going on with this thing. So it says I'm at the first step of, I'm trying to converge on the first step of my strategy. That is actually where I am right now. And I'm waiting for, I've got the capacity I wanted. I've got the installation status I wanted. I've got the traffic split I wanted. So I'm waiting for you to move forward. So we can see, thank goodness, all of the pods are in place. This is my kind of step 0 position. So I'm going to go ahead and tell it, yes, please advance. Because I don't have an old release, if I try to send traffic to any of the services, I won't get anything. So I'll say, go ahead to step 1, not R, which will tell it, you should be at the state described by step 1 in the strategy. And so if we go back to Google, we'll see things happening. I'm scaling up on my pods here, and I can go to the services now and actually start sending traffic somewhere. So I'll do that and then start sending traffic. So cool, I'm hitting a thing. And let's say I just discovered that, oh, hey, actually, after this // I wanted the pod name, but I forgot to put in my chart that it should inject that environment variable. So I have a bug in my configuration. So I'm going to finish the release that we have by going to the final step. Oops, excuse me. Two out of 2. This will converge to the right number of replicas, which is 4, as defined in my values that I parameterized the chart with. So while that's working, we'll go ahead and make a change to my application object, just like I would edit a deployment, so that I can create a new release and fix this bug. So the bug here is in the chart. So I have a different version of the chart with the bug fixed. Let's say it's version 3. I'm pulling this chart from a chart museum that I have deployed into the same management cluster, but it could be anywhere. So let's go ahead and do that. I'm not going to change anything else. I'm not changing the image. I'm not changing the values or anything like that, the strategy, just the chart. So now that I've edited the application, I can see that I have 2 releases, not just 1. And if I go back to Google, we'll see that I have a whole bunch of new stuff showing up corresponding to this new release. So my traffic is still only going to the old one because step 0 of my strategy defines that the contender doesn't get any traffic at step 0. It's the staging position. And so what I need to do is advance my rollout strategy by 1 step. And that will get things to scale up and also add things to the load balancer in a 50-50 split. So now if we start watching our traffic, we'll see that we're kind of load balancing evenly between the 2, assuming the networks do not get clogged with garbage. But so we're balancing approximately equally between the 2 different sets of pods, and that's cool. one nifty thing about this approach is that our rollout process is totally declarative. So if I advance, I add my pods to traffic and I decide, actually, whoa, this is no good, I can go backwards to step 0. And so that will remove things from the load balancer and scale them back down. And so we should see our traffic going back to only the first release. Kind of, I've decided this was a bad rollout. I want to bail out. But actually, this is a good release. We would like it to be full on. We'd want it to be in the final position of our strategy. So we'll change the target step to 2. The controllers, the operators will converge everything to that state, and then we'll be in good shape. And that's pretty much the whole thing. That's everything I wanted to show, was basically just doing a rollout, kind of going forwards, going backwards. We'll see that after this new one gets all the traffic and all the capacity it's looking for, eventually the old one will be scaled down to 0, and we'll just have a bunch of empty deployments sitting in those clusters. And I can show you garbage collection if anyone's interested, but that's the gist of it. Yeah. I'm happy to take any questions if anyone has any. I know that was kind of a lightning tour. I'll also hang out on SIG Apps and Slack or on the call if that's possible afterwards, if anyone wants to have a more casual conversation about any of this stuff. But
I thought it was very impressive. How long was the development cycle for this tool?
This was for developers for about 4 months. And we're rolling it out internally right now. And so like one of the reasons we didn't just kind of immediately release it is that we're just starting to put production cycles on it internally. And we want to kind of work out the normal bumps that come with something of this criticality going live before we kind of throw it at the world. I see a question in the chat about looking at the SIG multi-cluster. That was one of my big goals at KubeCon recently in Copenhagen, was talking with the multi-cluster folks. So I showed them this and talked them through it. And basically, they're next on my SIG community call demo list to kind of get the wider perspective from their side on this approach to multi-cluster orchestration. This definitely isn't as flexible as the Federation v2 design that was demoed at KubeCon.
I mean, it may not be as flexible as Federation v2, but if you're looking for feedback as to whether there would be value to getting community contributions and potentially open sourcing it, I mean, I can only speak for myself, but I would say, yeah, go for it. I mean, multi-cluster deployments are something that people are definitely struggling with in the open source community. So even if it's not as fully featured, and even if it's not Federation v2 or full multi-cluster implementation, it provides a capability now, right, that people could actually use. So if you're looking to get feedback and participants, I would definitely encourage you to open source it.
Oh, cool, thank you.
Yeah, agreed. Give us the link.
Yeah, cool, okay. So like I said, I can hang out on SIG Apps Slack and or on the call if that's a possibility. And if there's any less formal Q&A or whatever, I'm happy to be available for that. Yeah, thanks all.
Well, thanks for the awesome demo. If there's no other questions, then I guess we'll move.
Ken, you're muted now.
Double clicked. So thanks again for the awesome demo. If there's no other questions, then we'll move on to project updates. If anybody wants to give any. Anybody on the line who'd like to give an update for anything in particular? Okay, so I can give a little bit of an update on workloads. There are a few new bugs open against job, cron job, a few against deployment that we're triaging and we're going through, kind of just doing a bug scrub. There was one patch that got put into 110 for job back off. That should get backported in the next 110 series release. Another test failure that was an upgrade test that we had to fix for deployment. And we're still working towards getting conformance wrapped around deployment and upgrading the EDE test to V1. Okay. All right. So if we don't have...
Well, I guess I'll give one on Helm real quick. So last week we noted that Helm put in a PR proposal to become a CNCF project. We actually presented to the CNCF TOC last Tuesday after this meeting to answer a bunch of questions. It'll be a little bit before they vote and they decide and they ask questions and we figure out where the right place is to live. This might be one of the things where something that is very Kubernetes targeted, where does it belong within the CNCF under Kubernetes or not? We're going to have some interesting conversations about it. We're pushing that issue. So that has now been presented to them though. And then I'll say on the community charts, I know that there's folks out there who might be a little frustrated at the speed things are being merged. One of the things that I'll say is we're working on the human way that we do things now has not scaled. We have been blessed with so many contributions that it is now no longer scaling at a human level. And we are now looking at ways to change up that model. Proposal coming soon, maybe even something we can share here in the near future. We're tinkering with different ideas and talking through stuff, but we're looking to play more up on the decentralized approach of things to give people more power in the way that works. So hopefully some more details on that coming soon. And I think that covers what I had for those. Somebody else may have more to give on that stuff.
Okay. So just looking at participant, Brian, do you have anything on case on it or just?
Hello. I released case on it 0.10 last month, or yeah, actually right before KubeCon. But what we're working on and some of the bigger things that are coming up that are being worked on right now are Helm Components. And what we're going to do is we're going to actually make it so that you can consume Helm charts inside of KSonnet. And so that would be the only update. We have a demo that was going to be next week, and I just actually pinged Matt and saying that next week is Memorial Day in the United States. I will not be working. So we'll see a demo hopefully the week after that. So whatever is after May 28th, and I'll give a full update and full view of what we have going on.
Cool. I see Kim on here. Is there anything that you guys want to talk about? Oh, okay. All right. So moving on to discussion topics. So we didn't have a lot for today. There was one thing that was discussed kind of heavily at KubeCon that I wanted to bring up just to get a feel from other members of SIG Apps about where they're at with it and what they think about it. So I don't know if everyone's familiar with OpenShift, but OpenShift deployment configs have a notion of lifecycle hooks. And lifecycle hooks lets you do things like at a particular point in your deployment's rollout, you can launch a job that would, for instance, trigger a schema evolution for a database. That's a pretty common one. And there's a proposal open for deployment lifecycle hooks in the community. So it was something that I've iteratively heard requested, and Kargakis was the one who initially opened up the proposal. I just wanted to see if there were any thoughts on whether others feel it would be a useful feature or whether you think we have enough in terms of the core controllers right now, and it's something you'd rather build on top as an extension. Just kind of wanted to get a feeling for what people thought about that.
So I know OpenShift deployment configs, which I believe heavily influence Kubernetes deployments, have that concept. That's probably why Nicholas was opening that issue. They've definitely been useful for us for things like you said, for schema migration type things. So just my 2 cents.
Here's a question. Is this something that should be, because it's application specific, is it the kind of thing that should be a lifecycle hook inside of deployments? Or is it the kind of thing that should be in an operator? How do operators approach and cover over this? And then, you know, lifecycle is one of those things we talked about in Helm, and because you can get so application specific, how do you have something generic enough? You're not a lifecycle management tool. How much into that do you want to be versus giving other things the ability to do that? I think it's a hard space.
I think it's I think there's probably a spectrum, as with many of these things, where like the more sophisticated your lifecycle gets, the more you're probably going to want a true operator. But if you just want to do something super basic, like initialize the database schema or something, maybe you don't want to go write an operator in order to cover that. I mean, that may be an argument for it's not necessary because there are other tools, but that would just be my thought is like, if I want to do something super basic as part of my deployment, do I want to have to sign up for the complexity of a full operator lifecycle or some of these other tools versus being able to add a one-line field to my deployment schema?
Yeah, I mean, a really simple one is before I install my thing, I want to make sure that the CRD is installed and at an acceptable version that my thing will work with, right? There's a really simple lifecycle case at install time. And then how much further after those kinds of use cases do you go before we say we draw the line, you got to use something else? If maybe we had an idea of that, it might help codify how much should be in there.
So I guess the reason I wanted to bring this up is because I'm not entirely sure this is something that you can do well with a third party or with a custom controller, unless you don't use the existing workloads primitives, right? So there's no way to really pause a deployment and then launch something and then start it again. I mean, there are tricks you could do. There's kind of hackery that you could get around, like maybe you mutate a pod so that the readiness check fails and that blocks the deployment's rolling update. You could delete the image from a pod. That would probably just cause it to block, but that's going to cause error conditions and you really probably don't want to do it that way. So, I mean, one thing that we want is for people to be able to leverage the existing workloads primitives to build a higher level orchestration on top of it, operators, custom controllers, and so forth. So I guess my concern was primarily, are there good workarounds for lifecycle hooks that you can use outside of managing pod sets yourself and implementing the lifecycle hook, right? Like, I don't want everyone to have to go re-implement deployment so that they can have deployment plus lifecycle hook and then see that proliferate across the community with like many custom implementations and many bespoke implementations, as opposed to just doing it once in core and letting everybody leverage the functionality. But before we go down the path and devote resources to doing it, I do also want to kind of make sure it's valuable and that the community is on the same page.
I'll second what Ben said, and actually to answer your question, Ken, about there is a reasonable option that you create your own CRD that will do the initialization that you care about, and then will just kick off the deployment. But the problem with this approach is that you need to know how to write the controller, because basically you will end up writing one, even very simple one. It requires some knowledge about the API, and additionally, it requires you to deploy your controller onto the cluster, which means you are deploying your controller, you are deploying your actual application. This is supposed to be serving that simple use case. I want to invoke this simple two-liner, one-liner script that just initialize database or perform some initial configuration once or eventually every now and then. And then, so I don't see any easy way these days, other than something like lifecycle hooks. There are options that you can solve this. They are good options. Not every has to be hackery, but they require knowledge and in some cases they will require privileged access to the cluster, because don't forget that creating CRDs is not something that a user can do if he's has access to a limited set of resources. For example, OpenShift Online, or you have a dedicated piece of a cluster for yourself. You cannot deploy CRDs because you need to have a cluster scope resource to be able to do so.
Yeah.
And we don't have anything like that that will allow creating namespace scoped CRDs. And I know that Tomasz was interested in having something like that, but these days we don't have anything like that, which means in managed clusters, you are not allowing people to do simple stuff.
Sure. Well, I just want to ask a question about the deployment config lifecycle hooks. Do they only fire at the beginning of an update and at the end, or can they fire intermittently during or only an update based on a trigger, let's say the number of pods that have been updated?
No, there was just, if I remember correctly, we have just one at the beginning and at the end.
No, there's also a mid hook. I'm not sure exactly when it fires, but there is pre, post, and mid.
So pre and post are definitely doable, and those are doable well, right? Like again, caveated with everything that Majek just said, you can make those work. It's the mid one that I don't see how you can implement cleanly.
No, I think that's reasonable that we can start with just the pre and post. Honestly, I haven't used the mid one, but the pre and post I've been using heavily for, well, most frequently for databases, but yeah.
So
go ahead.
Oh, if somebody else had something first, they can go. I was just going to jump in and say, from a practical standpoint, Helm actually added hooks in that fire at certain points. They deal with install, delete, upgrade, and roll back. And there's even a special case for CDs to deal with the kinds of pragmatic things that folks have had to deal with. And, because this is when you're installing something or upgrading it, there are some real world cases where you get into light lifecycle, those couple of line things. And Helm has had this for quite some time because it's needed to do certain application things. And you actually find this for Helm, it makes sense because you find this inside of other package managers. If you went inside of like apt and some of these other things, these kind of events can occur that you want to do stuff. And so it was approached that way. But the only way I know of to do this without something like Helm today is to use an imperative tool. And Helm is probably doing this imperatively. I haven't actually looked at how the code works. Like if you look at Armada was designed to install OpenStack inside of Kubernetes. It's a heavy use case that I don't expect this kind of tooling to solve for. But it's very much, install this thing and then probe to make sure it's there. And then once it's there, you can go to the next steps. And that's because of just how OpenStack installation is. You've got to require certain things there before you can get to next things. You can't really just give it an imperative. There isn't a tool to give an imperative or declare. You have to, a declarative config to. It happens step by step. You have to control. And that's what we do today. If you really wanted to make all of this declarative, then it could get really, really, really super complicated. So you've got to draw your line of what we'll do. So the question is, how much of this should we make declarative?
No. The use case that you're, Matt, describing is specifically for building complicated workflows. And that's definitely something that we don't want to see being implemented in the primitives that we provide in Kubernetes. If you have a complicated use case, as you mentioned, that you need to wait for something to happen and then do this or that, you either implement some type of a workflow solution on top of the primitives that you already have, or you write the operator. In both cases, the flow that you are expecting to happen is super complicated and cannot be expressed through simple lifecycle hooks like the ones that we're talking. This is supposed to be simple, one type of one-offs. You can compare that to, for example, CRDs versus API servers. CRD is supposed to be simple. It's easy to write CRDs, and you have a custom resource definition for yourself. If you want to have some more advanced features around the type, you can go for writing your own API servers. This is the use case and the difference that we're trying to address with the lifecycle hooks. We want to provide simple primitives to work with the current objects, current resources that we have. If you want something more complicated, fine. These are the other options that you can go with, and go ahead, feel free. If you're looking for some one-off that will initialize database schema, that's probably the most common use case. This is something that is perfect for the for those lifecycle hooks.
Yeah. In this case, I was actually more or less just getting at, if we do this, we need to communicate where this should be used and where it shouldn't, so people know where to go to other tools. A communications thing, right? And then just to share examples of what Helm did, because it's a practical problem. So it's already been done elsewhere. I'm just sharing.
Yeah, that I agree with. It definitely outlining that this is only addressing simple use case. If you want to have something more complicated, then there's either Kubeflow, there's CRDs, or whatever else that we can come up with and point people so that they just know how to look, so that they connect the dots easily without trying to reinvent half of the Kubernetes on their own.
Cool. And then I guess my only other thought was that if we did this, do we want to do it uniformly? Does every workload controller get lifecycle hooks? And my initial thought would be like, if we're going to do this at one place in the API, we would want to do it for deployment and at least stateful set. I'm not sure if lifecycle hooks for daemon set makes sense, but that's something we would also have to consider.
Yeah, definitely worth starting with deployments and adding for stateful sets. The remainings, I don't see any reason to add those to jobs.
I don't even know what that looks like.
I don't think that does make sense. You can embed whatever logic you have in a job itself, so it's pointless over there. Daemon sets, I would say that have an option for it, but we don't have to implement it until somebody will ask for that. But definitely stateful sets and deployments is a place to start with these.
The thing about daemon sets, so stateful sets and deployments both go for some target number of replicas with a different type of lifecycle management for the pods themselves and different guarantees. But daemon set is sensitive to the number of nodes selected by its node selector, right? So it's kind of hard. It's not clear what end looks like for a daemon set, right? Nodes can come, well, depending on, I guess in general, nodes can join and leave the cluster at any time. And if the selector selects a new node that comes in, all of a sudden you're deploying a new daemon set. So there's no notion of the daemon set is done when it's this large. It's done when it's deployed the task that it needs to across the set of nodes that it selects. So I just conceptually don't know what that lifecycle looks like. But definitely something to think about.
So I have a question building on this, though, if you don't mind. So if I'm writing stuff that's going to go do this, and I'm writing it in a generic sense, say I'm going to write something and then share it with others, and they're going to be on varied versions of Kubernetes, how do we detect if a cluster has this in it yet or not? Do we just have to have knowledge of the versions, or will there be something around feature detection? This just came into my mind because now we're talking about iterating on stable APIs and the features they have. Do we now need to know features per version of Kubernetes and build that into our thinking and distribution, or then feature detection on top of being able to figure out, is this feature here or not within a subcontroller? I don't know. This just occurred to me, and so I was throwing that thought out there for others, because that's a problem when you have to share and people are cross versions.
I mean, generally speaking, if you're going to roll up features into a stable API, you'd want to release them at various degrees of stability themselves, right? So you're managing a feature. Usually you would do this with feature gate flags. So you would have to know if the feature is enabled in your version of Kubernetes based on the flag. When you roll out with alpha, it's going to be disabled by default on almost all distributions, unless that distribution says that we feel that the alpha feature is stable enough to configure it as on by default. In practice, I haven't seen that very prevalently. When it goes beta and it's on by default, then effectively it's enabled. The questions there really become around rolling forward and rolling back in the event that you roll out something with a new feature and then you feel like that particular release is unstable and you want to roll back your distribution of Kubernetes and now the feature has been disabled. That could be tricky if you deployed and started using it. So we'd have to think carefully around that. It's not.
Yeah, but think about it this way. You're a tool deploying something into Kubernetes. How do you have knowledge about what's enabled or not in that cluster to detect it and then maybe throw a linting error, right? To say your cluster doesn't have this feature of the stable, you're dealing with deployments and now there's a beta feature in there. Is it on? Is it off? Is it available? How do you deal with that as something that's deploying it into it? Not cluster management, but app management. And talk to the guy, like, what would those flows be like?
We don't have a discovery API for features per se. You can only discover resources and what resources are available via the discovery API. That's more of a meta question. Should we enable a way to like label a feature? I mean, I guess you could detect, I think you actually can get the feature flags out and determine if the feature flag is enabled.
One possible option to address this was to start with a feature through annotations as long as it's alpha and only promote it to the full-blown field inside of an object once it reaches beta. And
at
then,
that point, you can't deprecate it.
Yeah, but that's what I'm saying. As long as it's alpha, you put an alpha annotation on an object to know that, yes, I want to work with the alpha feature and whatever. And then only once you are migrating to beta, you can ensure the higher level of stability for the for that. And
I still don't think that you won't answers Matt's meta question. Like, even he's asking, how do I discover that this is available on a particular cluster version and modify my business logic to adapt to deal with multiple versions of Kubernetes, one that may have the feature and one that doesn't. I just don't think we have an answer around that right now.
Actually, you can verify what's in the definition of the resource, whether the field is there, which means it's beta or higher. If it's not there, you can only assume that maybe annotation is supported, which means it's alpha. It is a usable approach. That's what I was targeting.
But that tells you that everything's present. If you somehow change the structure of it in between, now you've got to start detecting the change of the structure. Is that it?
You could use the open API spec to look at the actual resource definition and say, is this defined?
Yeah, that's.
But then you're still encoding. You'd be encoding. That's tricky. You'd be encoding open API parsing from the discovery API into your tool, which I don't know. If I was going to use it, my general approach is that do it based on Kubernetes version. So I know if I'm at 110, it's available. Use only stable features that are released at a particular version and code against that version. Don't use things that you feel are too unstable to include or that might be deprecated, has been my approach generally.
It differs from the approach that we do in E2Es usually.
Yeah.
Because in the E2, I remember a discussion, I think with Brian some time ago, about that we don't want to rely, at least internally in Kube, in particular versioning names. That's why we have the discovery. That's why you have the open API descriptions, so that whenever we're actually looking whether something exists in the cluster, we are verifying the function availability either through resource, maybe not necessarily through field. At least I don't recall any tests, but through verifying if a resource is present is something that is happening a lot in our, like across the entire E2Es. That's the thing that we do. Version, for users, for apps, yeah, that's a reasonable approach, I'd say.
Yeah, I was just going to add the complication comes on with, there's this idea that the core Kubernetes is looking to move slow and not change very quickly, wanting to layer things on via the ecosystem now. And there's been a number of times where SIG architecture has said, let's not put this in Kubernetes. We're starting to have the tools with CRDs and custom controllers, do that as an ecosystem thing, and then clusters can opt in to have it. So features per version, right, there's the core of Kubernetes, but many of the things going forward are going to be ecosystem things that are installed in that cluster. And so when it comes to feature detection and knowing what version of what is available and how it works going forward, it may not just be as simple as saying, well, this version of Kubernetes has this, so we can trust these APIs. It's now can be about how do we know which ones CRDs and controllers are installed in the cluster and how do we take advantage of those? And so it could be more complicated.
But detecting a new resource that's a custom resource definition that's been installed in your cluster is actually fairly easy. And it's a little bit different from trying to detect whether a feature that's behavioral, that's based on the presence of a field, is available in a particular version of Kubernetes dynamically using the Discovery API. Like for the CRD, all you have to check is the resource installed? If it's installed, then you know it's available. Dealing with evolutions of CRDs is still kind of a work in progress too. That's something we're still trying to figure out. Like if I evolve the definition of the CRD in a breaking ways, how do I detect which version of the CRD is there and how do I interact with those?
And how is it simple so people can just do everything the same way instead of having to have different ways of doing stuff?
Well, I think it was what you brought up in terms of doing things slowly in the core APIs makes a lot of sense, right? So like if you're adding a custom resource definition to extend, or an extension API server to extend the functionality of the cluster, that's a use case going forward that we're working with and we expect to be more prevalent. But it doesn't mean we're not going to do anything in the existing resources. So while we're not generally adding a lot of new resources into the core APIs, adding modifications and adding new capabilities where necessary to the core APIs is something that we're going to do. So it's not like we're not doing any features on the core APIs whatsoever. And I guess the standard way that people have been dealing with it is primarily doing version skew detection, just knowing that I don't build against this until it's beta. If once it's beta, it's stable. And I need to be at version 110 or 111 of Kubernetes in order to leverage this feature. Then maybe we could do better, but I think that's the most prevalent way I've seen it done in the community thus far.
Especially that it was proven to work okay with there's so many changes that happened in the core, and by core I mean the stuff that lives since the beginning, like pods or replication controllers. There has been some changes to every single of those API, and they're like stable in GA since I don't know for the past 3 years, since I remember basically. And we did modify a lot in the pod spec, in the pod definition itself. Be that a security related or whatever. So it like Ken said, it will happen. We will evolve those API. And as long as you're not breaking backwards compatibility, it's fine. It's just that, And the worst thing that could happen if we start implementing new API versions of the resources every single time we will be trying to add something to it, we would end up in a hell managing that many different versions of those API groups. We already have a quite significant number of the groups. We got to the point that there are somehow more or less stable somehow manageable. And if we start introducing every single feature as a new version, it will be a pain. And like literally every single person, and especially those that are consuming the API, would be yelling at us seriously.
Speaking of which, as a topic we should discuss at some point in the future, deprecation of previous workloads APIs.
Replication controller?
No, replication controllers v1, that's around forever. But I was thinking more along the lines of extensions v1 beta 1 deployment, extensions v1 beta 1 daemon set, applications v1 beta 1 staple set, applications v1 beta 2 staple set, daemon set.
Let's start with the extensions v1 beta 1. I had a goal to get rid of the extensions v1 beta 1 API by the end of last year, which unfortunately did not happen. But I think it's doable for this year. I'm not sure how much of other stuff are there, but I feel pretty confident that with all the workloads that live in extensions v1 beta 1, they should be removed in the next version.
Well, I don't know about, so I think
next or at least 2 up.
I think one thing that we'd have to do before we do that is make sure that they're not enabled by default, which I think, did we do that for extensions yet?
It's not something I would be worried about whether they are enabled or not. I think the most important bit that we care is that the data that is stored in etcd is encoded using the new API, the apps version.
Storage migration is definitely like the technical problem that needs to be solved. But in terms of communicating to users, we probably want to disable it by default so that you actually have to take action on your cluster in order to continue using it. Because that's a very strong signal as you upgrade that this is going away soon. So it's a way of unambiguously communicating our intentions to the rest of the community to make sure that they're doing the right things and they don't get burnt to a place where, oh, wait, I didn't do my storage migration. I got to jump through a bunch of hoops in order to actually get this off. So before we remove it entirely, I would say not enabling it by default would be a good step.
So the migration should happen automatically, because what we did is, and I think if I remember correctly, that happened in 1.11. In 1.11, we changed the cohabitation for deployments, daemon sets, stateful sets. I think I would have to check. We changed the cohabitation in such a way that previously all the resources were saved as extensions v1 beta 1 in etcd.
Now they're v1 by default.
Yes, exactly. Right. Which means every time you touch every single resource you touch in 1.11 will get re-encoded and stored with the new version. This opens the path to disable the API in 1.12 and a complete removal in 1.13. That's reasonable.
It would be the fastest we could do it.
Okay, that's fine with me. Yeah.
Okay. Cool. Okay, we only have 4 minutes left. Is there anything else anyone wants to talk about?
Hi. My name is Jian. I'm new here, by the way. I'm from Alibaba. So we have one feature request. I want to hear you guys whether it makes sense or not. So the request is we want to upgrade a port. We want to do in-place upgrade of the port. Basically, we don't want to tear down the port while upgrading the port. So
what property do you want to update? The only thing you can do right now, you could change the container image. That would be about the only thing you can do in place.
Yes, that's what we want. We want to change the container image, but without tearing down the port.
You can do that.
Yeah, we can do that. So we want to see whether it makes sense to add at the deployment control level. So like adding a new loading update strategy, something like that. Say update the port without tearing down it.
So you want to do in place update of images only. There's some other discussion about doing a thing called image streams, which would do something, it would give you a similar capability. The only thing about image streams is they're kind of, it's a different way of thinking about it. Like it's not, image streams don't necessarily lead to reproducible deployments very well, but they allow you to continuously update the image without changing anything else around the infrastructure.
But that still restart pods, right? I mean, recreate the pods.
I think image streams just do it in place, right? They're not going to change the resource limits. So in theory, you could implement it in a way where you just update the container image in place without killing the pod altogether or releasing the C groups. Mm-hmm. If all you're updating is the image, right? Like, so I mean, like what we can't do in-place container resizing at the moment. Mm-hmm. So vertically scaling pods isn't really a thing. We can't do in-place network reprogramming without tearing it down, I don't think. I mean, in theory we could, but we don't. So about the only thing you really can change is the container image. Adding a rolling update strategy for all the workloads controllers to just touch the image would mean you'd have to try to detect image skew. I mean, it's doable, but it's probably non-trivial. Like, you'd also have to take into account which hash the image is, right? Like, because you can't just do it based on a string comparison that might not achieve the desired result. Mm-hmm. Which is why I kind of think image streams might be the way that you'd want to do it in practice. But I mean, if you want to open a proposal, we'd definitely as a community, be willing to look at it.
Yeah, so this is just we have use cases which require this, and we want to see at the controller level. We don't want to add for every controller, so just deployment controller or something that makes sense. So so this can support some of our use case. So the image stream you're talking about, is it a controller or something? So because I'm not quite familiar with that. The image stream you just mentioned.
OpenShift has a feature called image streams, which allows you to automatically detect the update of an image and change the image of a container, right? So instead of like updating the deployment manually, you detect that, let's say you're at tag latest and latest actually changes value. It'll roll out a new image for your containers. And that might be a more...
it will go actually to roll out a new deployment for you.
Well, normally it will trigger a deployment. I believe there is a mechanism that Clayton wrote that will actually directly update a pod with the new container image for working with Kubernetes resources. So it kind of can be both, but yeah, the original way
was to do a new deployment.
Was to trigger a lifecycle action with the deployment.
Yeah, and the reason for triggering a new deployment is that we are injecting a full poll spec, meaning not the human readable, nice poll spec, but rather one that contains a specific ID of an image in time that you are targeting at when running your applications, so that both underlying replica sets or application controllers are pointing to a specific Docker image by ID.
So that's, and the benefit to doing it the latter way is that it's declarative, right? And it provides full rollback. If you do just image stream where you do container injection and image resolution automatically, but you don't trigger a full rolling update,
you lose the history.
You lose the history. You lose the ability to roll back. And it's also very, very tricky to do infant mortality detection, because you don't know which is it.
In theory, the history is in the image stream itself, so you can go back to what the image stream used to point to. But it does seem like we haven't stopped and asked the question of why is this needed? I mean, I assume it sounds like the goal is sort of that it's a lighter touch way to restart the pod where you're not getting rescheduled. But what's the motivation?
So we're actually running out of time.
Sure.
But typical reasons I've seen are for very large images. But even then, it really doesn't matter. Like, it would be good. So I would say this. We're running out low on time. We have to finish up. But definitely, if you're interested in doing this work, open a proposal in the community so that we can have a more thorough discussion and have it recorded in a KEP. And we can go from there. It's not something we're saying we definitely won't do, but I think it's not something that's trivial enough that we can say, yeah, this is how we're going to do it, and we'll sign up to do it tomorrow. Does that sound fair?
Yeah, I just want to hear thought whether this is okay. I mean, I don't want to see that everyone is opposed to it. Then that's not what I think.
I don't think it's generally everyone is opposed to it, but I do think that it's something that requires a full design that we can actually look at, give feedback on, and as a community proceed with, as opposed to something we just say go, no go.
Yeah, sure, no problem. Yeah, I'll do that. Yeah, thank you.
All right, we're running a little over, so thanks everybody. Thanks Ben for the awesome demo, and we'll see you. Actually, I believe are we going to cancel next week due to Memorial Day? So last announcement, we will not be meeting next week. It's an American or US holiday, Memorial Day. We'll resume the following week in June. All right, guys. Thanks.
Thanks, everyone. Bye.
Bye-bye.